Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0113, indicates that the intake air temperature, IAT sensor circuit, is experiencing high voltage levels. This code is pivotal in assessing the vehicle's air intake system, and addressing it is crucial for ensuring optimal engine performance and fuel efficiency. The IAT sensor, usually located within or near the mass airflow (MAF) sensor, measures the temperature of the air entering the engine for proper air-fuel mixture calculations. A high voltage reading can lead to erroneous data sent to the Powertrain Control Module (PCM), which can affect overall engine performance. This code may come from a single source or various interconnected components. In the following slides, we will explore the details of this DTC, its symptoms, possible causes, and a structured troubleshooting process. DTC P0113 indicates an issue with high voltage output from the IAT sensor, directly impacting the vehicle's engine performance. The IAT sensor plays a critical role in determining the air temperature entering the engine, informing the PCM for optimal fuel mixture. Typically, this sensor is positioned close to or integrated with the MAF sensor, ensuring accuracy in readings. When high voltage is detected, the PCM may incorrectly adjust fuel delivery, potentially leading to a lean or rich condition. Various factors, such as damaged wiring, connector issues, or a faulty IAT sensor, can contribute to this high voltage reading. It's vital to diagnose not only the IAT sensor, but also the surrounding components to isolate the root cause effectively. Several potential causes can trigger the P0113 code. The first possibility is a defective IAT sensor itself, which may send erroneous high-voltage signals. Additionally, poor connections or damage at the MAF sensor can lead to communication issues between the sensor and the PCM. Wiring problems, such as frayed or broken wires, can also cause false readings by accelerating voltage levels. In some cases, issues may arise from the PCM, particularly if its software is outdated, affecting its ability to interpret sensor data accurately. Lastly, intermittent faults may present sporadically and can complicate the diagnosis, as they may not always be present during testing. Drivers may notice several symptoms when DTC P0113 is present. One of the most common signs is noticeable engine performance issues, including hesitation or stumbling during acceleration. Additionally, increased fuel consumption may occur, as the PCM could incorrectly adjust fuel mixture due to faulty input from the IAT sensor. The vehicle may experience overheating if the air-fuel mixture is significantly off, leading to a lean condition. Furthermore, the check engine light, CEL, will likely be illuminated on the dashboard, prompting the driver to investigate. Lastly, a poor acceleration response can occur, diminishing the overall driving experience. Recognizing these symptoms early is crucial for timely diagnosis and repair. The first step in troubleshooting DTC P0113 involves verifying whether the issue is active or intermittent. Begin by turning the vehicle's ignition to the on position without starting the engine. Utilizing the Honda Diagnostic System, HDS, check the parameters for the IAT sensor. You will want to look for the voltage reading, which should be below 4.92 volts during normal operation. If the current conditions exceed this threshold, the failure is confirmed and one can advance to the next step. If not, the issue may be temporary, necessitating a check for poor electrical connections or loose terminals related to the IAT sensor, MAF sensor, or PCM. Make sure to refer to freeze frame data if it is available, as it can help in replicating the conditions under which the fault occurred. Following the verification of the current conditions, the next step is to investigate potential failure areas further. First, turn the vehicle to the off position. Disconnect the MAF IAT sensor 5P connector to prepare for testing. Using a jumper wire, connect terminals A, number 4, and B, number 5, of the connector to simulate normal sensor operation. After making these connections, turn the vehicle to the on mode again. Recheck the parameters using the HDS. If the IAT sensor reading now exceeds 4.92 volts, this indicates an issue with the MAF IAT sensor, and it will need to be replaced. If the reading is still incorrect, proceed to the next troubleshooting step for further diagnosis of the circuit wiring. In this phase of troubleshooting, we will focus on potential issues within specific wire lines affecting the IAT sensor. Start by turning the vehicle to the off position, and then carefully remove the jumper wire. Next, power the vehicle to the on mode. It's imperative to measure voltage between the specified test points. With the MAF IAT sensor 5P connector disconnected, you should measure between test point 1, number 4 of the MAF sensor IAT sensor 5P connector, and test point 2, body ground. Ideally, you should see a voltage around 5.0 volts. If this voltage is present, it suggests that the circuit to this point is intact, allowing you to continue diagnosis. If the voltage is not at the expected level, further inspection of wiring and connections may be necessary, leading you to the next steps in the troubleshooting process. Step 4 focuses on verifying the integrity of the SG2 wire. Begin by turning the vehicle to the off mode and jump the SCS line using HDS software. Subsequently, disconnect the PCM connector B, 51P, to allow for continuity testing without circuit interference. Continuity must be checked between test points 1 and 2. Test point 1 refers to number 5 on the PCM connector B, while test point 2 is number 5 on the MAF sensor IAT sensor 5P connector. If continuity is confirmed, the SG2 wire is functioning as intended. In such a case, check whether the PCM has the latest software version available. If the software is outdated, updating it may resolve the DTC. If updating does not fix the issue, substituting with a known good PCM can also be considered and may clear the DTC. The fifth step is focused on checking the integrity of the TA wire. Start by turning the vehicle to the off mode once again. After that, jump the SCS line using the HDS tool. Disconnect the PCM connector B, 51P, as preparation for continuity testing. The continuity check will be conducted between the designated test points. Test point 1 is identified as number 30 of the PCM connector B, whereas test point 2 refers to number 30. 4 on the MAF sensor IAT sensor 5P connector. If continuity is confirmed on this line, the TA wire is satisfactory. Similar to the SG2 wire check, it may be prudent to update the PCM if the software version is outdated or to test with a known good PCM. If either of these actions clears the DTC, it indicates that the original PCM was at fault. Conversely, if continuity is absent, repairs will be necessary to correct the open circuit in the TA wire between the specified points. After completing the necessary repairs and replacements related to DTC P0113, ensuring the effectiveness of the work done is vital. First, using the HDS, confirm that no DTCs are currently present. This step is crucial as it verifies that the previous error code associated with the IAT sensor circuit has been resolved. Following this check, it's advisable to reevaluate the operation of the IAT sensor to ensure that it reads appropriately and that the engine is performing accurately. Finally, conducting a test drive will offer practical confirmation that all systems are functioning as expected. and confirm the stability of the repairs. It's always best practice to monitor the vehicle after repairs to ensure all issues have been thoroughly resolved. Conducting preventive maintenance is essential for avoiding future occurrences of DTC P0113. Regular inspections of connections associated with the MAF/IAT sensor will help identify any potential problems early, preventing issues before they escalate. Keeping wiring harnesses intact and free of abrasions, kinks, or corrosion will ensure reliable electrical connections. Additionally, routinely updating the PCM software is critical, as manufacturers often release updates to enhance vehicle performance and accuracy. Implementing these preventive measures can extend the lifespan of your vehicle's components and contribute to overall performance efficiency. It's always worth checking manufacturer guidelines for maintenance schedules to stay ahead. In conclusion, DTC P0113 signifies an issue with high voltage in the IAT sensor circuit, which could critically affect the engine's performance if left unchecked. Understanding the role of the IAT sensor alongside the MAF sensor is essential for effective troubleshooting. Through a systematic diagnostic approach, potential issues can be identified, from wiring continuity to sensor integrity. Regular inspections and updates are key to maintaining vehicle reliability and preventing future occurrences of this code. By adhering to best practices in repair and preventive maintenance, you can significantly extend the operational life of key engine components while ensuring safe and efficient vehicle operation. This proactive approach not only saves time and money in repairs, but also enhances the overall driving experience. Please like and subscribe to the channel. See you next time.